We're going to continue with systems of equations, but now we're going to start looking at nonlinear systems. So far we've looked at linear, where we've had substitution, graphing, and elimination, right, with two lines. Now we're going to just use substitution and graphing, and we're going to have maybe one line or maybe no lines and different graphs. So to start with, the functions we have seen so far, we've seen linear, right, that's our line. We've seen quadratic, that's our parabola, our U-shape. And we have the square root curve, which is what we consider the swimmer's arm, right? Now we're going to have any version of these in our system. So to begin with, we might have a linear and a quadratic system, right? So a line and a parabola. So we have different options for how many solutions we can have. One, it can cross twice, so we can have two solutions. Or it cannot cross at all, and we have no solution. And we also have the option of it crossing one time at one point where we would have one solution. Now these are just examples. We have many different options. Like for example, I could have a vertical line that's also one solution. Right? These are just one example of many options when it comes to how many solutions we can have. Okay, but we won't ever have anything different than one, two, or no solutions for linear and quadratic. So for example, I have a linear equation and a quadratic, right? The first one's quadratic, there's my x squared, and then the bottom one I just have x to the first power, so that's my linear. Alright, so if I want to solve this one, I'm going to do it algebraically, and that's by substitution. So I know that both of these equations equal the same thing. They both equal y, so I'm just going to set them equal to each other. So I have x squared minus x minus 6 equals 2x minus 2. This is a quadratic, so I got to set it equal to 0. So I'm going to subtract 2x. So I get x squared minus 3x minus 6 equals negative 2. And I'm going to add the negative 2, or add 2 to both sides, cancel out the negative 2. So we get x squared minus 3x minus 4 equals 0. Right? Remember, quadratics, you have several different ways of solving. One of them is completing the square. You have quadratic formula, factoring, and you can solve by graphing. This one's easily factorable, so I'm going to solve by factoring. This is a plain Jane trinomial, so my next step is to go to parentheses with an x in each of them. And I want to multiply to my c, negative 4, and add to b, negative 3. Right, and to multiply negative 4, add to negative 3, I have a negative 4 and a positive 1. And then my next step to solve, I set each of those equal to 0, which means x has to equal a positive 4 and x has to equal negative 1. Okay, so in this case, I'm going to have two solutions, but I'm not done yet. I need an xy coordinate point for my solution. So I have two x's, and I have to plug them in to find my y. So if I plug in 4, I'm going to end up with y equals, and you can plug them into either equation. I'd pick the linear. Linear is easier to plug in, so you only have one x in there. So 2 times 4 minus 2. 2 times 4 is 8. 8 minus 2 is 6. So that means one option is 4, 6. Then I'm going to do the same thing with negative 1. So y equals 2 times negative 1 minus 2. 2 times negative 1 is negative 2. Negative 2 minus 2 is negative 4. So my other answer is negative 1, negative 4. So I have two solutions to this system. Other types of systems you might see a linear and a square root, right? So if I have a line and a square root, they could never touch. So that would be no solution. Or it could cross one time, and I have one solution. Or it could cross twice, depending on the slope and the shape of your swimmer's arm. So I can have two solutions, but I can't have more than two solutions. I can have 0, 1, or 2. You might also see a quadratic and quadratic. So in this case, for the first one, they are never going to touch. They're going in opposite directions, so I could have no solution. Or in our second case, they touch one time in the middle, so I could have one solution. Over here we've got 2. And then the last one looks like I have one quadratic, but if I have 2 equations that are the same quadratic, the same parabola, that's where it would be infinitely many. All right, just like with our lines, with linear systems, you can have infinitely many if it's the same line. Same thing here. So if I've got the same parabola, it's going to be infinitely many solutions. So now I've got no solution, 1 solution, 2 solutions, or infinitely many. You may also see quadratic and square root. All right, so I can have where they never touch at all, no solution. I can have where they touch once, so that'd be 1 solution. And then I can have where they touch twice, and that would be 2 solutions. So I cannot have more than 2 solutions with a quadratic and a square root. And finally, we might see square root and square root, 2 square root curves. So I can have them going opposite directions, right? Or I can have one that's a little narrower, flatter, and they would never touch. So I'd have no solution. All right, I could have where they touch once, right? And that would be 1 solution. And I could have where they are the same square root curve, just like we did before with 2 quadratics, and that would be infinitely many. So anytime you're doing a system with the same type of equations, you have that option of it being the same curve, and so you have infinitely many solutions. So it's important to know what your graphs look like so that you know if you start solving and you get 3 solutions that it isn't possible. All right, so you have to know what you're looking at, what your graphs might look like so that you know you're on the right track.